Hello students, this is Niteen Mohod, and through this video we are going to see the actuators. Actuator is basically a motor operated by a source of energy which is used to move or control the mechanism of the system. Though you may find this definition complex, it will be clear when we will discuss the topic step by step. Actuators are in the form of a current, hydraulic fluid. Hydraulic fluid means the machineries which are using the liquid fluid power, for example excavators, power steering systems of the four-wheelers, lifts, etc. Then pressure or pneumatic pressure, where the application of pressurized gas is done to produce mechanical motion. Actuators are subdivision of transducers transforming or changing input electrical signal input into motion. Electrical motors, pneumatic actuators, hydraulic pistons, relays, comb drivers, piezoelectric actuators, thumb biomurphs, digital micromirror devices, and electroactive polymers are some of the actuators. These are some of the examples of actuator. Actuator drives motion in mechanical system which converts electrical energy into some form of the mechanical motion. Electromechanical actuator and its principle. Now, as the name suggests, electromechanical, it is very clear that it is an actuator which converts energy from electrical to mechanical. For example, DC motors. Working principle of electromechanical actuator is permanent magnet DC current converts electrical energy into mechanical energy through interaction of two magnetic fields, and these two magnetic fields are produced by, one is produced by a permanent magnet assembly and second one is produced by an electric current flowing in the motor windings. These two fields results in a torque which tends to rotate the rotor. As the rotor turns, the current in the windings is commutated to produce continuous torque output. Here you can see the construction of DC motor shown in the diagram. Every DC motor has 6 basic parts. One is axle, as you can see here. Then it consists of rotor, then stator, which is a stationary part, rotor is a moving part, commutator, this part is called as the commutator, then the field magnets, which are shown as north pole and south pole magnets, and brushes. So here you can see the brushes, this one and this one, which are in touch with the commutator. Mostly in DC motors, the external magnetic field produced by high strength permanent magnets, which are these magnets, because of which the high magnetic field is produced or external magnetic field is produced. Stator is a stationary part of the motor and it includes the motor casing along with two or more permanent magnet pole pieces. So the casing of the motor, you can say, and the permanent magnets, that totally considered as a stator or the stationary part. Rotor together with the axle, means this rotors together with this axle, and attached commutator rotates with respect to the stator. So stator remains stationary while all this complete assembly rotates like this. The rotor consists of windings. You can see here the coil wound on. The rotor consists of windings, generally on iron core, electrically connected to the commutator. Geometry of the brushes, commutator contacts and rotor winding is such that when power is supplied, the polarities of the energized winding and the stator magnets gets misaligned and the rotor will rotate until it is almost aligned with the stator's field magnets. As the rotor reaches alignment, the brushes moves to the next commutator contacts and re-energizes the next winding, and the process goes on continuously. The given example is of two pole motors because we have used here two strong magnets. The rotation reverses the direction of current through the rotor winding, leading to a flip of the rotor's magnetic field, driving it to continuous rotating. Principle of electrothermal actuators. It works on the principle of resistive heating. Now, electrothermal, the thermal means temperature and electro means the electric current. And electrothermal actuators, you can come to know the meaning of this from these words itself. It works on the principle of resistive heating, and that is, heat generated in conducting arms causes expansion and thus deflection from the normal position. We will see it through the diagram, there it will be very clear. The devices normally use DC current, which when disconnected causes the arms to cool and returns to the normal positions. So when heat is produces, the expansion of the arms takes place, and when the arms are cool, they comes to or returns to their normal position. Polysilicon is the material of choice because it is suitable for the surface micro machining techniques, and doping amounts can easily control its resistance. Bent beam electrothermal actuator. This is one of the kind of electrothermal actuator. Its principle is on passing current through a V-shaped beam anchored at both ends, thermal expansion pushes the apex outwards due to Joule heating or ohmic or resistive heating, it is also called, the process by which passing of current through a conductor releases heat. That is the meaning of this resistive heating or Joule heating. Displacement of the apex is a function of the beam dimensions and slope and can be increased by cascading several actuators together. Now first we will see single bent beam actuator. Here we can see the diagram of single bent beam. You can see the bent beam here, which is anchored at two opposite ends, and this apex, this moves outward or come back to its normal position depending upon the Joule heating effect. Displacement of the apex is a function of beam dimensions and slope and can be increased by cascading several such actuators together. Such several actuators can be connected together or cascaded together to get the or to increase the effect. Forces acting on a bent beam thermal actuator. Here in the diagram you can see the different forces. The force acting on the anchor here, and accordingly the apex of this bent beam will move up or down. So I hope the idea of bent beam thermal actuator, basic principle of actuator, DC motor is clear to you. Thank you.